Hey, welcome to another System 63 How-To videocast. Today we're going to talk about modulation in the system. Pretty simple, works just like CV in any modular synthesizer. So we're just going to look over a few of the modules that work with CV in System 63 and see a little bit about how they work. This isn't going to make any noise. This could be boring for some of you. But keep in mind, when you hear those things that I do on Patching Chaos that sound so wild, all the CV is exactly how it's done. So knowing CV is the perfect way to make great sounds and great sequences and great pieces in System 63. So let's get into it. First off up here, I started off by doing a simple model of another low-frequency oscillator, which I happen to love, which is the one that was in the original Moog modular. Of course, I took it further than what they did because, you know, it's software. We can do those kind of things. So to start with here, let's have a look at standard sine wave. We're going to connect the sine wave. Now, as you notice on here, there's two sines, two saws, two tris, two pulses. Reason for this is the top one is a straight sine out, and the second one is an attenuated sine. Now, what that means is this volume knob right here, this turns up and down the amount of the second output for whichever wave type it is. Also on the saw, this switches it from a saw to a ramp. So saw, of course, goes down after the peak, and a ramp ramps up to the peak. And we'll see those as we go on here. So let's start off with the sine. We've got that connected up to our oscilloscope. Let's click on this. It is low frequency, so we need to pull this time way, way down here. Cutting off the AC on the signal, it's your preference or not. I always tend to keep auto on. If you don't, you can set your levels pretty easily using this. All CV in System 63 ranges from -1 to +1. Does not go outside of that. If you find something that does, let me know, because it shouldn't. Everything is -1 to +1 for CV. Any multiplication above that happens within a single module, and nothing is ever passed that is greater than or less than -1 to +1 volts. So now we have a standard sine wave output. If you notice, we play with the frequency, and it changes the width of the sine. And the frequency is using the frequency setup for System 63. So if you don't understand that, we will have a podcast in the future just covering the how the frequency system in System 63 works. It's really pretty cool. Everything is technically beat synced. It's just that you can set it down to very fine settings. So now, let's move on here. Let's go have a look at our standard attenuated saw wave. So there we have an attenuated saw wave. Okay, now if we invert the saw, you see it becomes a ramp. Oop, sorry about that. Mouse battery still low. Let's go over to the triangle wave. Basic stuff. Same thing with our pulse wave. Very basic stuff. Just pulse. Now, on this particular LFO, you can also set the width of the pulse for creating different effects in using that pulse wave. Straight up and down, 50% duty cycle is a basic square wave. In other words, the positive part of the signal is the exact same length as the negative part of the signal. And the line running through here shows your 0 volt, positive 1, negative 1 volt. Okay, now the cool part of this oscillator is when you have two of them. Now what we have going on here, I'll move this out here because it's a spaghetti mess of wires. Of course, these take the reset signal. And now we have the sine from the second oscillator running into the CV1 of the first LFO, saw to the CV2, and pulse to the CV3. These are all unattenuated signals. And coming out of the first, we have the same running to the second. This is a technique known as cross-modulation. Now, what you get out of this, let's go back to our sine wave. What you get out of this is largely dependent upon how you set it up. So let's have a look. Let's bring in that first sine wave from the second LFO. Now the thing is, sometimes it takes a while, since these are really low frequency, sometimes it takes a while for the oscilloscope to catch up. Wish I had a regular oscilloscope that I could show you. The reactor modes just aren't fantastic. Oh, there goes the mouse battery again. Well, you set up for a podcast and then things don't work the way you expect them to. Let's get some crazy LFO going there. That'll make this catch up. Okay, so let's pull these out again so you can see what happens. As we go in, there's our standard sine. Now, here is our sine being modulated by the sine output of the second. Now you say, that's cool, but what do you use that for? Well, you run that into the CV for filter cutoff or all kinds of things throughout System 63. For right now, we're just concerned with knowing how to get to the different waveforms. Now, if you notice here on the second LFO, we have the saw inverted, so it's actually a ramp. Let's bring that ramp in a little bit here. And now if you notice, it's actually flowing through your oscillation better. Now we have the pulse coming into CV3. Let's pull in some pulse along with this. Now the beauty of all of this really comes in with playing around with that frequency to get exactly what you want. This would be very interesting on a filter right now. So with cross modulation, you can do that sort of thing. Now we can also go in and go to the mixers section, and much like the Moog style of CV, you can take the mixer 4 And we can take the sine output, and let's take the pulse output, and then come out of the CV output of the mixer. And this allows us to mix the two CV signals. Now let's take another one of the LFOs in the system. We'll come down here and go to Modulation, and we will go to the multi-LFO. The multi-LFO is a completely different beast. It requires a clock signal and a reset. So now this LF1, LF2, LF3, those are just the waves that are chosen from the front panel. You can also you have direct access to every waveform that the LFO makes. We use LF1 and LF2 here just to make it more simple for you to see and visual. So now let's set up a triangle wave on the first LFO and a pulse on the second. Now if we go to the B tab on this has a built-in clock divider, so I made a mistake here. This needs clock directly from the clock, and we don't need the divider anymore. Now, on this type of divider, you'll see it throughout the system. This first button here switches it from a divider to a multiplier. Second button is a doubler. So if you've got it set to 8/1 multiplying, this makes it 16/1. So let's bring this down to 2/1. We'll take this one to 4/1. And now we will mix them into our signal. So now you see we get some really, really nice, crazy stuff going on. Now this isn't the only type of mixer that you can use in System 63. We also have several others. They don't live in the mixer department because they're just CV utilities. So they're under utils. So if you look in utilities, then you can find things like, let's see, okay, there it is, CV Mixer. Now the CV Mixer does some things that the standard Moog style mixer does not. So let's have a look at this, shall we? We will get rid of this. We'll get rid of the Moog style mixer. Actually, didn't mean to get rid of the other LFO. Let's go back here. Now we'll take the sine output from the first one, LFO1, LFO2, and LFO3 out of here, and then the CV out into our oscilloscope so we can see what's going on. Now, this also allows you to see what's going on. This is actually a CV meter. It's laid out just like a VU meter, with 0 being center, -1, +1 being the extremes on the ends. These are just attenuators for each of the signals, and these are inverters. So if we want to invert everything, or invert half the signal, this is actually a slew limiter for your CV mix, which just helps to smooth out that CV. So let's pull this back up. So you see now we don't have those as many sharp points. It's nice and rounded. Gives a nice smooth flow to a really chaotic CV mix. And attenuation, allowing you to drop the signal to nothing or up to full. So now what else can you do with CV? Let's go back in here into Utilities, and we'll go to CV to pitch. All I'm going to do is connect this up to the first one. This is basically just a little utility which takes a -1 to +1 CV signal and then turns that into a -12 to +12 pitch offset. So this is really handy for using in the additive section of the sequencer core. Works really cool. So let's have another look at something else. Logic switch. Let's connect up a couple of CV outputs to this and show you what's going on. This is both a gate generator and a trigger generator. So we're going to take LFO1 and LFO2 coming out of here and connect those into the logic switch. Basically, what this means is when LFO1, right now we've got it, if we set it to AND, that means when both of those CV signals are positive, then we get a green light and the gate is opened if it's switched on down, or it triggers if it's up. And the difference between a gate and a trigger: gate stays on the entire time that it's open, and a trigger is just a short burst. Triggers are used in things like drum modules, that kind of stuff. But we have AND, OR, which means if one or the other is positive, then we get a gate open. And the final logic in here is exclusive OR, which means one or the other is positive, but not both of them. So you have this. This is really, really handy. You can do lots of stuff with this. I especially like to use this with the additive and skip in the sequencer core setup. Works fantastic. So that's about it for today for CV. Hope you enjoyed the podcast and some of the things that we can do in System 63 with control voltage. Until next time, I'm Mike Romans, and thanks for checking out Romans Audio System 63.